I'm Greg Maxey. I'm a solution architect in our sales organization at Electric Cloud, and my partner here, Laurent Rochette, is also a solution architect, and he's in our professional services organization. And what we'll be talking about today is DSL at scale. And what that means is the use of the domain-specific language of electric flow for implementing source code-based orchestration. And when we talk about orchestration, what we mean is the whole life cycle of software delivery in terms of all the automation aspects of it. That is from code check-in, through the various unit tests, through the artifact management, to deployment into various environments, staging, and release out to production. So in the next 20 minutes, what we'll be covering is a number of topics. So first of all, kind of the motivation. So why this talk? And then we'll talk about what was life like before DSL, and then give you a specific example of something that Laurent and I worked on in terms of a very large-scale implementation that was based around DSL at a financial services institution. And then what's next? What can you be looking out for? How can you get your hands on DSL? Perhaps how you can contribute to it as well. So last year, we introduced DSL at this event, at the DUS Summit 2015. And we anticipated that it would be a pretty big deal. I was pretty excited about it. I'd started using it for about 6 months prior to that and had some really nice successes under my belt as a result. And so I wanted to share that, and so gave a presentation. And for those of you who weren't at the presentation last year, I'll give you kind of the 30-second rundown of what DSL is. So DSL is an authoring language. So it's based on Groovy. And if you don't know Groovy, Groovy is an interpreted version of Java. So if you're familiar with the syntax of Java, it's very easy to learn the syntax of DSL, the Electric Flow DSL. And Electric Flow DSL gives you basically access to all of the APIs in Electric Flow for authoring, execution, and other data extraction type things. But in terms of authoring, it makes it very easy because it's an idempotent language and some other fancy things that make it very easy to capture something and to do refinements of models once you got something in place. So indeed, we saw good adoption over this last year. A number of our customers are using DSL. Anyone using DSL here? Nope. Well, we do have some of our clients who are indeed using it. And indeed, we found that it really improves our efficiency. So for me personally, I do lots of demo development, lots of customer implementations, as does Laurent, and we both experienced improvements in how we do our day-to-day jobs. So what I'm going to do is pass it on to Laurent, who has lots of experience doing implementations with Electric Flow, and so he knows what life was like before DSL. Yes. Laurent.
So Greg is in pre-sale, so he's promising all the world to the customer, and then I'm coming in post-sale, and then I have to deliver what he's promising to customer. And sometimes, it's not quite the same, but so we usually manage. The problem before DSL is you had to do pretty much everything through the UI, which is fine. If you have to create, one application model or a couple of applications, it's fine. It's a lot of click, and we have some tools to do, copy and stuff like that. But it's a lot of clicking. The other option we had was to use Perl, because we have an API with Perl. Perl works really well, but the problem with Perl is if you create an object and that object already exists, well, you have to take care of verifying that the object is not there, because if you try to recreate it again, you get an error. So you had to do all that error management around it, which was possible, but it was kind of a little tedious and require a lot of testing and stuff like that. So the nice thing with DSL is, as Greg mentioned, it's idempotent. So if you say, I want to create a project and the project already exists, DSL say, yeah, that's fine, I'm just going to modify what you change. The other issue we had with before that is, in order to move your code, for people who didn't attend my session yesterday, to move your code from server to server, you have to deal with either project export or maybe do some plugin, which is nice, but you have some issue and you have this versioning and stuff like that. So you had to take a lot of additional action which were time consuming and error prone. With DSL, you now have a very nice piece of code. You can also put it into your SCM, which make really coding a lot easier. And in the past, if you were deleting an object, especially in the earlier version of our tool, you didn't have version tracking. So you were losing your object basically, and you had to go back to a backup or be sure you had some kind of a safe version saved somewhere through an export and stuff like that. With DSL, you put everything into, as I said, in your SCM, and if you kill it, that's fine. You just go back to your SCM, retrieve the last version, and you're good.
So now what we're going to do is talk to you about the example we had, or our experience at a financial institution where we implemented at scale. So hence the name of this presentation. And here are some of the challenges that we faced when we were presented with the requirements. So this particular company had lots of applications. In fact, the first number I think they told us was 20,000 applications. So I'm thinking, we got this nice UI, it's really easy to use, but 20,000 times however many clicks it takes to onboard an application, that's not possible. They also had slightly different mental models of how deployments work. So they had this notion of a server-oriented infrastructure. That is, some guy in ops was responsible for all of the application web front ends. And someone else was responsible for all of the login procedures for all the applications, which isn't quite the way we thought about how deployments would work. So one person would just do all the deployments for his set of servers, and those would be independent of all the other pieces of a particular application. So we had to get our head around that and figure out some ways to accommodate things of that nature. Also, as a bank, they use everything. Every imaginable technology, every imaginable language. I didn't put COBOL here, but you can bet they had COBOL as well. So Java, .NET, everything. And they had lots and lots of applications coming down the pipe. So they got lots of existing ones and a high rate of creation of applications all the time. They were looking at doing they're on a 3-week sprint, so a 3-week release cycle. And also, again, it's a bank, so they have very strict regulatory and compliance requirements. Also, they have strict uptime requirements. You can't go shutting down all of your regional offices, your branch offices, and you can't shut down the trading floor, right? You've got to have the software available, but of course you need to be able to update it sometimes, so you have to work within these very tight service maintenance windows. So these were some of the specific requirements that we were asked to implement with our orchestration service. So the ability to onboard all of their existing applications, or at least a bunch of them, the ability to onboard new teams, so accommodate new teams and their new applications in a kind of a self-service mechanism, be able to cover at least 80% of the use cases. So, presumably 80% of the applications are kind of similar in terms of their architecture and the approach to deployment. They also had, again, bank, very strict requirements on who can do what within the system. So who's allowed to push the green button to go ahead and do this deployment? Who's the one who could push the button to bring down this particular server? And who can see the data that's associated with end customer information, right? Personal information. So you got some very strict requirements on the access. And then interestingly enough, since this was a service that the IT organization would be rolling out to the developers and the release teams, even though it's implemented inside of Electric Flow, we had to follow the same structure as any other software or service that's being developed at the bank. So Electric Flow had to manage the deployment and the release of Electric Flow content. Kind of meta, right? It's a little... So we had to manage that as well. But, of course, this is all readily accomplished, no problem. I'm in sales, so this is really easy. We'll just get our service team on it and we'll be successful. So.
Thank you, Greg. So when we arrived, we found a couple of things to do. So first, the customer had some way for their employee to define what were their application, so they define them in some kind of portal, and they basically give us that information through some JSON format. The advantage of that is it allows us to start working in parallel with what they were doing. So because when we started, their UI was not ready, so we were able to basically to mark up the JSON file. So when we started, we were just reading the JSON file from the file system. And when their UI was ready, it was just a matter of either for them to pass it to us through a REST API call, or for us to call them through also the REST API. So that allows us to work in parallel. I mean, it's a good technique. It's a good technique to have. So the people were basically defining, what kind of machines they want, how their application is composed of the different components and stuff like that. And so by taking this information and feeding it through our procedure in electric flow and everything being written in DSL, we were basically able to create a model that fit exactly what each internal customer wanted to do. The advantage of that versus something that our colleague Chris did at a different customer using properties, where you say, well, I want that and not that. When you do that, your model basically includes everything. So when you run it, the customer see, oh, I have a pre-step and I have a post-step and I have a reboot. And if it's not used, basically it shows that, skipped or something like that. With the way we did it, as we were creating the model basically live for each application, each customer, we didn't have to have that because the model was created, each time, at least once for each customer. So that allows us to basically give to the customer a model that basically represent exactly what they're doing, and they don't see all those steps that they don't necessarily need. So that's make for a cleaner output. So we did everything with DSL, creating the different model. We also use DSL to basically import our code to the different servers. So as Greg mentioned, we have this meta system. The idea behind that is, well, if you push some code to manage the automation to the production server, what happens if you break it? Well, suddenly nobody can release anymore. That's pretty bad, especially when we have this kind of scale. So what you want to be sure is the code you're writing to help the customer is going to work. So you have to basically follow the same process that the customer follows for their own application, dev, QA, prod, or whatever many steps. So we did the same. We were pushing our DSL, using DSL on each of our servers, that each of them were mimicking basically the customer environment, dev prod, dev QA prod. And so we were also using DSL for that. Everything that way is in source control, which is great. So you have history, you can be sure everybody is doing their stuff, you can link to Jira, to Rally, to whatever system you have. So then when you do a check-in of a new feature in DSL in your code, you can link it to the requirement, to the story, to a bug, whatever you do normally for your own development for your application. So we can use basically the same principle now for our own code. So that's making it a lot easier. The only thing we didn't manage are credentials. Credentials in Electric Cloud are basically typically, login password information. For obvious reason, you don't want to put your password into your SCM. So those were basically created by hand. We just named them the same way on all the servers. So they were created once and then we never touch them. So we had basically a file structure that kind of mimic, the structure we had inside Electric Flow. So we had a project directory. Then under each, we have each individual project. Then we have the procedure. Each procedure directory had, with a procedure name, had a Groovy file, a DSL file that match. How do I create my my procedure? And then we had the different steps, which are basically when you put your command in Electric Flow, were in their own file. So we were not basically mixing, a DSL code and Perl into the same file. Because the problem when you do that, you have problem with the $, because the $, is used in Perl and it's used in DSL. So you have to escape everything. That makes it very complex. The other problem with that is if you use some kind of a clever editor, which I guess most of you do, well, you have a file and you say it's Groovy. So it's nice, you see all the Groovy syntax, but in the middle, you put some Perl, and then it's totally freaked out by that, and even with the quad. And so that way, if we can keep the commands themselves, which are in Perl or in shell command, outside in their own file, basically the editor is a lot happier, and that makes our life a lot easier, finding the matching quad and all this kind of thing. So that's basically what we do. So all our code was also basically managed by Groovy procedure and stuff like that. And it works pretty well. You put everything in SCM. And it also allows you to have different people working on different parts. I'm working on a project, on a procedure, maybe on a specific step, and Greg can work on the next step or something like that. So we don't step on each other. In the past, if you work with Electric Flow and you had a full export, you could do it, but you had big, huge file, and that was not really manageable. So basically, what we had was, a project per application group. So we were putting all the objects we were created for the model under one project, which make it easier for us to apply access control. The higher level you can do your access control, the better it is. Avantika did a nice talk on that yesterday, so I refer you to that on the video. We also use what we call snapshot. A snapshot is a way to basically take a picture of your application model. Because what's happened is you define your June release and you say, well, I have that application, I'm doing that way, I don't need a reboot. And then came the next month's release and somebody say, oh yeah, but now I need to add a component and I need to add maybe an application and now I need a reboot. Well, the problem is if you don't take a snapshot and you use the same model, so what happened? Your model for the June release and the July release are not the same, but you're using you modified your original one. So by taking a snapshot for your June one, when you create your July release, for example, it doesn't really matter because you have this picture, and even if you modify it, you're basically safe. So that makes it a lot easier, and it also avoids for us to have to create basically a new model for every release. So we can keep at least the number of objects to a minimum. The problem with doing that is it's become a little complex to be sure of what version to install. So we basically created what we call a manifest, which is, for the developer, an easy way to put that information into Electric Flow and basically say, well, for the July release, I want version 1.1. And for the August release, I want version 1.3. And, well, maybe I'm going to do a couple of looping on that because of 1.2 was not that great. But it doesn't affect the other release because you have to realize that when you're in a bank and you do the June release and the July release and the August release, the three are pretty much in play at the same time. The June release is in QA, and the July release maybe at this time only in dev, and the October release is starting to get planned and you're starting to create your model. So you need a way to be sure that those releases and those versions don't step to each other. So we make a use of the property sheet and properties to basically manage that. And again, one of our colleagues, Chris, did a presentation, yesterday? 2 days ago on it. And as we can use properties everywhere in Electric Cloud, they're like variable into your traditional language, you can have property on every object into the tool. So it's really easy to create properties closest to the object or the places where you need them. So we created them on release, on application, on environment, and that way it's a lot easier for us to manage instead of having everything in one location that make it a little harder to follow. So. Oops, one more. Okay. So basically it's what it looks like at a high level. So the user using their own front end basically define what is the release, what is the application and component, what is the infrastructure, basically where do they want to deploy those applications, what we called environment tier. So through some JSON, we basically run a couple of procedures in Electric Flow, and those basically create a bunch of objects, release, project, application, the whole modeling that our tool is using. And if you haven't seen it yet, I encourage you to go to our booth and ask for a demo, and you can see how it works. So and everything again was done with DSL. You know, everything is created into a project. You know, typically specific to each business unit. And from there, you know, the model is created, and it's up to the user to basically go click on, say, you know, start my release, which is going to start the pipeline, going to do the deployment, and so on. You know, manage error, doing reporting, and everything, which is, you know, typically what you see when you use our tool. We use simply the DSL and, you know, JSON to basically create everything, because, as I say, when you have one to create, it's easy to start directly on the right. When you have 100 or 1,000 of application to do, you know, clicking doesn't really work. So, Greg.
So Laurent has done a good job at summarizing a lot of the advantages, or telling you a lot of the advantages that we realize with the use of DSL. We're going to talk about some of the caveats at the end of the presentation, but here are some of the key things that we observed when working with DSL at this financial institution. So first of all, source code based orchestration. And so what that means is that the code is in a format just like any of the other applications that have been developed at the bank. And we're not relying on the proprietary database representation of electric flow, right? So they don't have to get into the nuts and bolts of that. Instead, they've got exposure to source code. So that was one key thing. The other key thing is data-driven. So you remember Laurent said they had a web portal that would generate a JSON data structure. That was basically a description of all the application information, the release, and infrastructure requirements. Electric Flow would consume that, and through DSL, crank out the appropriate models for the particular end user request. Multiple teams can work on developing these assets, right? Because it's all in source code. You're not dealing with one big export model in Electric Flow. So you can use merging techniques. You can use IDEs, as Laurent also pointed out. And the last one is a little bit subtle. Laurent described it, but I think it's one of the biggest, most important aspects of utilizing DSL in this way. And that is your end customer who's presented with a model, okay, I have a release model or an application model that's specific to me, is going to have their specific values hard-coded in, all the way down to the version of the component. So you have the name of the component. And this is in stark contrast to kind of a template approach to doing modeling. So if you needed to create a template that would accommodate all 150 groups that are developing software in your organization, you'd need to have a huge parameter screen with each of those values, and you're presenting your end users with a lot of information that's not necessarily relevant to what they're working on. So some of the business impact of the use of DSL, I see our time is running out here. It enabled this self-service approach. So the IT organization that was responsible for onboarding applications didn't have to respond to a ticketing system to implement this. Instead, the development teams themselves will be able to go into a web portal and implement that. Electric Flow and the DSL enables the separations of duties and a number of other things, which I'm going to have to let you read when you download these slides in the future. So I encourage you to take a look at DSL. And here are some resources or things to consider with DSL, is that all the things that we've been learning, we've been telling the engineering team about and encouraging those the team to implement some of the functionality. Here's one of the things that was added recently to the product, is the ability to switch between the graphical representation of your model inside of Electric Flow and the DSL. So it's just a toggle. You can make an edit inside of the DSL and it appears immediately in the GUI representation. Also,
so internally, also engineering have been basically eating their own dog food. So they've created a testing framework using DSL. We've published it onto GitHub for customer to use. We've started to use it at this financial service customer. to basically to help trying to do some automatic testing and stuff like that. So basically you test your DSL model with DSL, which is great. ECadmin has not been, for people who don't know, it's kind of a helpful plugin to manage your server. Has not been transferred to DSL yet because I have still a bunch of customers running on older version, but I'm starting to basically migrate my other plugins that I've been working on to DSL because it's such a game changer. Urvashi did a presentation yesterday on Plugin Wizard, also released on GitHub. If you're an Electric Cloud customer and you do plugin, go give it a try. It's a game changer. I'm serious.
And so that particular thing that Laurent referred to is based on like the plugin Lite. So we found that we could do plugins in a much more efficient manner by using DSL. And indeed, we're taking many of our existing plugins and converting those into this plugin Lite format. So now it's easier for us to open source those and allow our customers and anyone else to contribute to that as well.
And it makes merging a lot easier because the DSL is a lot more granular than the full XML was. I remember, Leandro, I think you submitted an ECadmin patch, and suddenly it's a little harder for me to extract exactly what has changed. Here, that's going to be a lot easier.
And lastly, and some resources. And the last one is kind of the caveats, things to keep in mind. So as we said, we're merging, pushing stuff into engineering to improve the product, but there's still some things that linger and that need to be kept in mind. And one of the key ones is that the DSL is executed on the server. So if you've got a clustered environment, it can be a little bit challenging. They've added some functionality. Now we've got print line that's built in there. And one thing that bit us early on was that if you delete an application model, you lose the inventory information. So you need to be careful about some things like that. Anything else you want to say, Laurent? I think we're done.
I mean, DSL for us as professional has been really a game changer. So if you're a customer, I encourage you to try it. I think it's for us it's a differentiator. I don't think any of our competitor has any kind of DSL. I may be wrong, but that's really for us really a game changer. So give it a try.
Questions? Yes.
So is this DSL somewhat like EC Pearl and something that you continue to add features to it, or is it
Yes.
what it is now?
Yes, so you have the full API. So you have two different parts of DSL. So you have basically Leandro was asking if the DSL was like EC Pearl, which is traditionally your way to interface with electric flow. So the answer is yes. So in DSL you have basically two things. You have the whole API, so as you have in Perl, so all the API are there. And you have also all the constructors. So instead of basically doing a create project, you can just say project and give all the attributes of a project, and that will create the project for you. And if it already exists, it's going to modify it only. We have a bunch of examples in the links that Greg mentioned in DSL sample. We have a bunch of examples. And yes, we continue to improve it. As Greg mentioned, in the last year, we've given a lot of feedback to engineering. And one of the examples is println was not there. So we had no easy way to print information during the evaluation of the DSL. It has been added in 7.0, and that's going to make our life a lot easier. So they continue to fix it. When we find problems, they fix them. We give them feedback for enhancement. And if you guys were using it, have some feedback, be ready for it. We'll be happy to listen to it. Another thing we've improved a lot is ACL. Avantika did a lot of work on ACL and DSL, and same thing. We fix some problem. We improve it, and so now we do all our DSL work, all our ACL work with DSL to Miniel.
Any other questions? Oh, Leandro, yes. Oh.
So we used DSL when it first came out, and we had issues with having an escape character, right? We can export or try to import, we run into problems. You touched a little bit on it in the presentation. Can you repeat again, how can we get away from that? We essentially stopped the use of DSL because we had to go in and add escape characters.
So Leandro's question, let me repeat it. So Leandro said that he and his organization utilized DSL in the early days and found one of the challenges was that with special characters, especially the $, because the $ is used for property substitution in electric flow quite often. And so you'd have to manage that $, to distinguish it from the electric flow property substitution versus the groovy or the DSL understanding of that?
So we have a couple of techniques for that. For the property, what you do is instead of saying dollar bracket, which is our syntax for properties, you do dollar plus bracket, and that way it's not substituted. The other thing, if the problem of escaping is more with different language like Perl, with a dollar sign, what we've done is, as I say, we put all the command where usually you have your Perl, and we basically say, command equal and new file and the path to the file, and you have to manage where the file is going to be read on the server. So either with a shared workspace or local workspace with a property to know where it is, or always the same directory. And that way, your Perl or your shell is into a different file, and that way you don't have problem. I can show you. I've put some code on. We have a new project on GitHub called Patterns, and that's what I was talking yesterday in the Lightning presentation. So I have some code there. So have a look, and you have my email if you have more questions. I'll follow up with you. Thank you.
Thank you so much. Have a good day.